In this video, we're going to look at how we make glycogen. So in the last video, we talked about how you can break down glycogen, and under the conditions inside your cell, this is exergonic. Delta G is roughly -5 to -8 kilojoules per mole. Therefore, if we want to remake glycogen, we need a different pathway. And this is actually very common when it comes to synthesis or metabolic strategies. When you break down something and rebuild it back up, you will often use different pathways. Because, for example, here the breakdown, -5 to 8, so it's going to be hard to go back up that hill. So let's just make different enzymes to take another path to get back to glycogen. So this is the basic mechanism to create new glycogen. First, you take glucose 1-phosphate, and you will react that with uridine triphosphate, UTP. This is catalyzed by the enzyme uridine diphosphate glucose, UDP-Glucose or UDP-G. Now, you're making what's called an activated compound. An activated compound just means like a high energy compound that's ready for synthesis. And you're going to donate this glucose unit to glycogen. So our overall reaction is glucose 1-phosphate plus UTP goes to UDP-G plus PPI. You can see delta G is actually 0, so this could readily equilibrate. But the reason why this happens is that once we have this pyrophosphate, that's what PPI is, water will go and split this pyrophosphate into two phosphates. And this has a very big negative delta G. So overall, our reaction has a very big negative delta G. And again, this is a common metabolic strategy. When you want to use a nucleoside triphosphate, chop two of the phosphates off as once, and those two are still connected into what's called pyrophosphate. Then those two pyrophosphates can be chopped again to two inorganic phosphates. You get a lot of free energy by doing this, and you can drive any unfavorable reaction. Alright, so once we've formed our UDP-G, the synthesis of glycogen is rather straightforward. You take your glycosol unit and you transfer it to carbon 4OH on a non-reducing form of glycogen, and you're going to form a new alpha 1,4 linkage. Overall, our reaction is UDP-G plus glycogen, number of N residues, goes to UDP, so our UDP is lost, plus glycogen N plus 1 residues. We have grown our glycogen by 1 glucose. Delta G is -13.4 kilojoules. And if we combine it with our previous step, glycogen plus glucose 1-phosphate plus UTP goes to glycogen, now with one more residue, plus UDP plus 2 phosphates. And we need to replenish this UTP if we want to continue with glycogen synthesis. So we do that with ATP. UDP plus ATP makes UTP versus ADP. So even though we're not directly using ATP in this, we're still burning ATP to add new glucoses to glycogen. And of course, this needs to be controlled somehow, and this is done by allosteric control. This enzyme is inhibited by physiological concentrations of ATP, ADP, or inorganic phosphate. It will become inactivated if it's phosphorylated. And if it's dephosphorylated, it needs G6P, glucose 6-phosphate, to be activated. And that makes sense. If you have a lot of glucose 6P around, that means you have a lot of glucose around. Therefore, start growing glycogen. Start growing your storage if you have a lot of glucose 6-phosphate around. Now, glycogen synthase can only add sugars to pre-existing glycogen chains. You cannot just take two glucose and link them together with glycogen synthase. Therefore, we need a different enzyme to get glycogen started. And that different enzyme is glycogen. That's the enzyme that creates our new glycogen molecule. And here's glycogen right here, surrounded by glycogen. And what glycogen does is that it will attach one glucose unit to the hydroxyl of tyrosine 194 on its enzyme. Once you have that initial glucose ready to go, then you can add 7 additional UDP donated glucoses to that chain. So your initial chain starts with 7 glucoses attached to this glucogen. Once you have this primer of 7 glucoses, glycogen synthase can take over and start adding glucoses based on the mechanism we saw in the previous slide. However, hopefully we know by now glycogen is a branched molecule, and so glycogen synthase only adds alpha-1,4 linkages. It doesn't make branches. To make branches, we need a different enzyme, and that enzyme is a transglycolase, specifically is amylose 1,4,1,6 transglycolase. Basically, it's just saying we're taking a 1,4 linkage and making it a 1,6 linkage. And this is different than the debranching enzyme we talked about in the previous video. So what's happening here is that we have 7 glucoses, and we're going to transfer those from the end of one chain, and we're going to add it to the C6 hydroxyl of a different glucose. That's how we get our 1,6 branches. Now, to transfer, our segment has to be at least 11 glucoses long, or else we will not transfer from it. And our new branch point has to be at least 4 glucoses away from where we started. This is just allowing for efficient glucose storage. And that's it for this video. I will see you in the next video.